Hi viewers, in this video I am going to explain you about the algorithm of this polynomial, to how to solve this polynomial. Okay, so I first read the question. Write an algorithm to accomplish the task for the polynomial p of x by given in following table. Here is the expression p of x. We first solve this algorithm for two methods. First we evaluate the polynomial p of x using iterative approach or using recursive approach. Then we divide this polynomial by x minus r, and then we find the derivation of the p of x. Okay, here is the solution. So first I will explain the algorithm by using iterative method. So here is the first step. Initialize the variable result to 0. Then we run a for loop I is equals to n to 0 in decreasing order. Then we first multiply the coefficient of a with x to the power I. Then we add the result of step a to the result variable. Add the constant term a0 to the result variable. Return the result variable as the value of p of x. Example. Here I have solved the example using the above algorithm using iterative method. Okay, here is the p of x 2x cube plus 5x square minus 3x plus 1 using the above algorithm. So you can go through this. I'll I'll send you this PDF in description. Okay, this is the second algorithm based on recursive method. Algorithm to evaluate polynomial p of x given in the table using recursive method. Okay, we solve this same question using recursive method. First, I define the recursive function. I name this using evaluate polynomial that takes parameters a coefficients. First, we pass three parameters. First parameter is a, which is list of array in decreasing order of degree. Then I pass d, which is the degree of the polynomial, which is in integer. Next, I pass the value of x. If the degree, first I'll check if condition. If the degree is 0 or t is 0, return the constant term a0, and we run this part in else. Otherwise, return the value of the polynomial evaluated at x. Then first multiply the coefficient at degree d with x to the power d. Then recursively call the function with degree d minus 1. Then add this result of step A and step B. We're going to add this result of A and B to the add function. Call the function evaluate polynomial with parameters A and, which is the degree of polynomial, and x. Here I have solved the example of the previous algorithm, which is based on recursive method. First I have defined, okay, here is the p of x 2x cube plus 5x square minus 3x plus 1. So you can go through this example also. Here I have solved algorithm for dividing polynomial p of x by x minus r. So we're going to first to initialize the quotient of polynomial q and remainder r to 0. First I will initialize q equals to 0 and r equals to 0. Then I will run a for loop for this, for each term of the polynomial from highest to lowest degree. Okay, first I have compute the value of current term quotient by dividing the coefficient by x minus r. First I divide the quotient by dividing the coefficient by x minus r. Okay, add the computed value to the quotient polynomial q. We add this result or computed value to the quotient polynomial q, which we have initialized to 0 also. In third step, compute the value of the current term of the remainder by multiplying the quotient of the current term with x minus r. Subtract this computed value from the current term of the polynomial. We are going to subtract this computed value from the current term of the polynomial. And in next step, add the computed value to the remainder polynomial r, which we have initialized to 0 also. And after the completion of this for loop, we return the value of quotient and remainder. At last, I am going to explain you algorithm of differentiation of p of x. Using this algorithm, we obtain a differentiation or derivative of p of x. Okay, so do this. First initialize the derivative polynomial d with 0. First we initialize d with 0, which is derivative of polynomial. For each term of the polynomial from highest to lowest degree. Okay, got it? Compute the value of derivative of the current term by multiplying the coefficient with the degree of the term and subtracting 1 from the degree in this for loop. After this completion of this for loop, add the computed value to the derivative polynomial d then return the derivative polynomial d. Here we got the derivation of the polynomial. Okay, at last is the end of the video. I hope you guys understood what I have said in this video. Okay, thank you guys.